So now that you have an understanding of Algorand Foundation, and we've also covered some of the DeFi projects occurring on here, it's time for us to look a little bit further ahead. Smart contract fundamentals, designing your first dApp. Let's go.
Hello, everybody. Making sure we can hear me, see me. Got my PowerPoint producer. We're good. All right, we're great, ready to go. Welcome everybody to Smart Contract Fundamentals, designing your first dApp, excuse me. My name is Russ Fustino. Like I said, I'm a developer advocate for Algorand. Very excited to bring this session to you. Got to tell you, I was panicking about a half hour ago. I rebooted the machine and nothing was working. With none of my PowerPoints, none of my Word, everything. So I rebooted it again. And, you know, when all else fails now, I used to say reboot, but really double reboot, and they'll take care of it. Anyway, good to go here. And I do have a little bit of a poll question to ask y'all. So if you can do that for me, I appreciate it. Let's see here if I can bring it up here. And let's go ahead and get you to answer some of those questions. And then we'll go ahead and continue on with the deck. And I'm going to get my lay of the land here straightened out. Okay, now we're cooking. All righty. So we got the poll going good, and I got my real estate all set up here to go through the first couple of slides. I'm going to have 3 questions for you, so I'd appreciate it if you can go ahead and answer that so I can get your experience level here. And let's go ahead and get started. So what do I need to know to build my first dApp? Well, first and foremost, what are the tools, right? As in any venture developers take, you know, what's my tool set look like? And well, what's the technology too? You got to know that, right? Where you're going with it. And finally, what are smart contract budgets? Something that you'll want to be aware of when you're building dApps, as well as how to create transactions from smart contracts. This is a fairly new feature. And then also how to deploy dApps to multiple blockchains might be of interest as well. And then how do you log from smart contract? And how to sing 99 bottles of beer on the wall. We've got that lined up for you today too. Lots of good stuff. And we got some polls coming in now, so I appreciate that. Keep on, if you can scan that QR code or go to slido.com and enter the 90225, we'll make a effort to kind of tailor this presentation to the experience level. Okay. So we're going to talk about getting started first, and then we're going to go into the AVM, which is the Algorand virtual machine, talk about that. We've got pooled smart contract budget, inter-transaction log support we're all going to talk about, as well as Teal and PyTeal. And then I got a little treat for you. I'm doing some debugging with smart contracts as well. We'll fire up the Teal Debugger and show you how to use that, as well as got a demo on Reach I'm going to show you too for building dApps as well. Reach is a great cross blockchain deployment tool using one code base. It's pretty fascinating, actually. So we'll take a look at that. All righty. I'm going to go ahead and move this slide over to the next question. Looks like we got about majority brand new to blockchain. Okay, very good. And so let's go ahead and get started. The first place you want to go ahead and start looking out at is the smart contract and dApps over at the developer portal. And I think seeing how so many people are new, I'm actually going to show 2 slides here as well, 3 slides that are and hide these and go ahead and take show these. So already your polling is coming in very handy. So basically, this is the proof of stake protocol Algorand has. You have great throughput, pegged at 1,000 transactions per second, even more nowadays, and it's going to go way up into many thousands as well. Under a 5-second blockchain, so true scalability. You have a great technical flexibility, a lot of SDKs, transaction certainty, no forking, very extensible platform, very energy efficient as well. Transactions, you can run actually a node on a Raspberry Pi. Cost efficient transactions are under a penny. And then you also have true security as well. You got the main areas for layer 1 features are going to be Algorand accounts, standard assets, which is like your tokens. And the accounts, by the way, you can have three types of those. You got the standalone, you've got multi-sig, where you have a threshold to sign off. So you have a group of 10 accounts, and maybe 3 have to sign off. The threshold would be 3 in order to sign the transaction. And then logic signatures, of course, too. And then also you got standard assets, which create tokens, both fungible and non-fungible. You got atomic transactions. That's really the secret sauce a lot of times in building solutions and tying a lot of different unique aspects together, or transactions together. Either they all work or they don't. And then we got smart contracts, or ASC1, which is going to be the majority of the session. There's also a reporting index or two as well. And this is the lay of the land in terms of the distributed ledger for blockchain. Really very simple in terms of the record types that you have here. And I'm going to put the third question up here. If you can do this too, it'd be great. Algorand blockchain is a immutable distributed ledger. So think about it as a block is a slice in time when all the transactions are written to the blockchain. And then also within that time interval, each transaction has to have transaction between accounts. So the transaction, we have a from account, to account, and then each account has associated with it assets, both ones that it is defining and one that it is opting into, as well as applications the same way, creating the application or opting into that contract. So that's the lay of the land in terms of the blockchain for those that are brand new to Algorand blockchain. Okay, so now what I'm going to do is I'm going to go ahead and close this up and go ahead and bring out Algorand.com. So let's go over here. All right, so this is our developer portal, developer.algorand.org. Lots of great things. We just redid this portal not too long ago. And there you can see the smart contract and dApp section. That's where you'll want to drill into tokenization, all about NFTs and security tokens, integration, integrating ASAs and all the SDKs are down at the bottom. And then also you have some really great docs here. So I'm going to kind of point you in the right direction there. A lot of getting started sections. You can see here on the left, you can expand getting started with, smart contracts, for example. You can go into like what's a dApp, and you get some really good information there. And then you also have building with Python. Here you have step by step. You want to go ahead and load up the Sandbox, which is really a great development tool. This will take moments, right, to configure. You just got to install Docker and then clone this repo, and you're up and running. You can use this as a node. So very painless, and it goes into that information as well. And then also we have all of the SDKs and REST APIs. These will have like information about your first transaction that you make. You see step by step. And we also have something really cool, which is the ability to see the actual thing in action through running the code. So at the end of a lot of these, you'll see a run the code, and we actually have replets out there. And this is great for those who just want to kind of learn it without having to install a lot of the stuff. This is a Python example. We have Python, Go, Java, and JavaScript are the official ported SDKs. Also, we have a really great ecosystem with a lot of other SDKs that are out there. But at this point, all you got to do is hit run, and everything will come out here. It'll just execute this whole application on doing your first transaction. And then you can kind of look at the code. You can actually do this in debug mode and hit breakpoints and do that kind of stuff. So a lot of cool stuff there. Going back over the portal, you also have a lot of great information in the way of tutorials, solutions, articles, all there. Great tools as well. This is the ecosystem projects I was telling you about. man, it's just a thriving community. You got a lot of Algorand IDEs here, monitoring analytics, developer forums. You got block explorers, wallets, and then take a look at all these SDKs, right? There's a C# SDK, Dart, PHP, Russ, Swift, Unity, brand new. This just came out, so I haven't even rolled up my sleeves and tried that yet. I can't wait to do some game development with that tool. So anyway, a lot of great stuff there. So let me go ahead and get back to the deck. I can give you a nice whirlwind tour of the site there. So let's get into the meat of the content here. So what we have is the Algorand smart contracts and smart signatures, where you have a smart contract that is on chain. Basically, it facilitates global and local storage. These are good for setting up things like escrow accounts or on-chain dApps. There's also something called smart signatures. These are simply used to sign transaction. A delegate contract is a good example of that, where you have the logic of the program has to return true to sign an account, which is normally the end of it for logic signatures. But in addition to that, you would also need to have an account sign off on it as well. So it's like a dual capability. So that's a good use right there with smart signatures. Also, all these technologies I highlighted up front are combinable. You can combine smart contracts with atomic transfers, Algorand assets, combine smart contracts with smart signatures. Also, you have TEAL, or Transaction Execution Approval Language. The contract is logic is written in TEAL. That's an assembly-like language. Also, we have a Python-enabled compiler called PyTeal that will generate the TEAL. And I'll actually show you that today in some demos. I got lots of code to show you. Smart contracts at a high level. Basically, you've got an application transaction there. There's going to be, making a call out to a smart contract, and then it's going to go ahead and grab information from the ledger. These could be accounts, it could be assets or whatever that are existing on the blockchain. And then it's going to determine if it's a pass or fail with the logic that it has. And then the contract can then write to global and local storage. Now, global storage, everybody in the blockchain will see it. Local storage is at the account level. And then the contract can also initiate new transactions. Very excited about that, because before you had to feed a transaction into a smart contract, now you can actually build an actual transaction. I'll show you that in the demos in a little bit. A smart contract, aka apps. You have the application transaction. You communicate with the application transaction. So you have two types of programs: the approval program, which is the meat of it, and then a clear program, which would be usually very, very simple. And once again, the TEAL program will be able to access global state as well as local state on the account level. And this is all referred to as the AVM. So what is an AVM exactly? It stands for Algorand Virtual Machine. So the consensus network observes when the smart contract app calls a transaction, and it sends it to the execution environment. So the execution environment is commonly known as a VM, or a virtual machine. And we have these VMs run on every node. All right. So it's a runtime within the consensus protocol, running on every node. And what does this mean? Well, an AVM contains a stack engine that evaluates and executes smart contract and smart signatures and program logic. And also, the reason for the assembly-like language in TEAL is really performance. We're very, very keen on performance in the Algorand blockchain, especially when, at the rate we're scaling out globally. And so this is really a good thing. And then we have some great tools. I'm going to show you to make that easier for those that are not keen on assembly language. And it's really not too bad. There's not that many opcodes in there to really get a handle on it. But, in the way of PyTeal, we're going to talk about in Reach as well. And when evaluated, then the transactions that they're called with either include that transaction in the next block or discard it altogether if the evaluation fails. So that, in a nutshell, is what the AVM is all about. There's a link there in the slide. I will have a link to these slides at the end as well, so you have access to all these links on our developer portal. Some of the features of the AVM include functions, looping, back jumps, recursion, real programming type stuff, which is great. And then allows contract to contract composability. You can create IDs for both the assets and smart contracts prior to block inclusion. So this is really great. So you can have a handle on that before it gets out to the block and you have to get it from the block. So this is really makes things speed up quite a bit. Mathematical precision now 512 bits with additional math opcodes, increased max program size from 1 KB to 8 KB, and then combines key value paired limits now for 128 per pair. It could be any combination. It could be 1 and 127 or whatever. It used to be split down the middle. Now you can do any combination there. Also, enables free transactions via transaction groups. You can send algos and ASAs directly through these smart contracts, control escrow accounts, pool smart contract execution, opcode budget, perform intertransactions, as well as new opcodes and including login support. Excuse me, log support. And so we did a video. We have this developer office hours every other Tuesday. And recently we did a session on this. So those are located at algorand.com/developers. Make sure you sign up for the next dev office hours. You're getting a big following on that. Some really great feedback. Folks seem to love it. And so we typically do a little presentation and then a lot of free form questions and answers as well. So let's take a look at a smart contract escrow account, how that actually works. So go ahead and deploy the smart contract then to the AVM. And you can get the Algorand address and unique ID, both of those. So the unique ID is a smaller number. The address is like a regular account address. So if you have to send algos from to an account, now you've got the from address that you can get for that particular contract. And then use that in conjunction with ASAs and atomic transactions and so forth. And then what you see here is basically you have intertransactions. These can do payment transactions. You can also set properties up and define an asset. So you can do all these transactions to create basically a transaction function with all the different properties. You have the ability to do freeze and clawback in ASAs, if they are designed that way right from the get-go, where you have those are mostly useful for security tokens if you're building some of those. You do have to opt in to another ASA, so you can do that as well with intertransactions. And also you need to opt into the smart contracts themselves in order to use them. So that's really very smart thinking on the part of Algorand, I might add, especially with the, creating assets. You just don't want to blindly have people, have these assets. You have to opt into it to want a particular asset. So that really helps prevent spam quite a bit. So I'm going to drill into 3 of those features now in the AVM using the SDKs. The first one is the pooled smart contract budget. This is one of the biggest questions we get from developers is how can I expand this budget to do maybe some more of the more expensive calls that are used in smart contracts. We're going to show you exactly how to make intertransactions and log support. You got a great demo there as well. So on loops and subroutines and pooled groups, you have basically an opcode budget of 700 per call. You can be pooled with up to 16 atomic application transactions. So that's really, really encouraging. So then basically by that pooling, you're expanding your budget to 16 times 700 or over 11,000 units. Also, like I mentioned, the file size now can go from 2 to 8K total for both programs, and upping the page's increased minimum balance. So you can see an example what the teal looks like on the right, on the top, and then there on the bottom, you can see what we're doing here in the code, the PyTeal, to create and assign group ID with these different app calls. All right. Then intertransactions, up to 16 intertransactions per app call. You have smart contract pay the fees, which is great. So the fees eligible for pooling and fees are the default minimum balance. They show up as intertransactions within an application transaction. Also, you have accounts that can be rekeyed to smart contract, giving the spending authority to the contract. So the account must be in the accounts array to spend from it. Now you can see on the right the kind of code we're going to be looking at here. So here we got an inner transaction up on top that's got two items in it. One is we're going to fund an account. We're going to do a transaction. This could be like an escrow account you might be setting up. So it's just a regular pay transaction. The second one is an app call to go ahead and maybe specify an app ID that you want to do to create an asset or use an asset. So a lot of things here are done, and we'll take a look at these. You have the sign group, and then also this is where you begin the inner transaction. You go ahead and set all your fields. You can see all the ones going to all the different asset fields you need to create when you're building an asset. Things like the unit name, the manager, the clawback, decimals, and then you go ahead and do the submit at the end, and that'll build the transaction we just built. So that's what you're doing there. You're building the transaction. Logging is a lot of fun. A lot of times you want to be able to log information out, and you now have that ability to do so. And so here you can see the PyTeal where you got a scratch variable and you're going to create the upper bound and lower bound of 99. We're just going to demo down to 97. We're not going to make you suffer through all 100 bottles of beer. Then we're going to go ahead and use our iteration, and the sequence is going to happen here. We're going to go ahead and do our iteration until we get down to the bottom. And then we also have PyTeal, like I mentioned. So this would be the Python, and it simply compiles out and generates teal. So very handy. On the debugging front, when you're debugging, it's going to entail three things: accounts, signed transactions, and approval program source. These get bundled into what's called a dry run request. And then the dry run request then facilitates doing debugging with teal debug. And this is great. It's a great debugger. It is through Chrome Inspect, and it facilitates, stepping through, setting breakpoints, and you can expand on all the stack space, scratch space, global and local variables as well. Some great documentation on the PyTeal site. So you should be able to learn PyTeal pretty easily, especially those that have Python background. And it seems at this day and age, just about every group I pull, the Python is just really, really high. I think Stack Overflow also came back with similar results in general for the developer community. And I got to tell you, I write code in all four SDKs that we support, and every time Python wins, in terms of the least amount of code to accomplish the task. It's just amazing. So a little bit of side commentary on that one. Hey, demo time. How about that? Let's go ahead and get going. Some demos. We're going to show you pooled smart contract budget, inner transactions, log support, and with the teal debugger. And then we got a little bit more with Reach we're going to show you too today. Okay, so let's go ahead and bring up the first demo here. And I've got the breakpoints already set here. Let me go ahead and clear this out. All right, and let's take a look. And what we're going to do, I'm going to make this a little bit bigger. Okay, there we go. And so what we're going to do is a little bit delayed here. Okay. All right, now let's go ahead and run this. So I've already got my breakpoint set for the talking points, and I do want to also show you what the makeup is here. Basically, in the folder here, we've got a file here called app.py, and app.py is the PyTeal. So what we're seeing here is we're going to go ahead and put in this verify function, which is very fat. It's a very expensive call. This is what's used to do signing. Now, we're not actually going to do a signing here. We're just going to use it to demonstrate this pooled resources and how you can expand your budget. And that's really it. And then you have a boilerplate conditions down here. These are the different facets of the life cycle of a contract, deleting, opting in, closing out, and executing that. So that very, very simple, very straightforward, not just a handful of lines to go ahead and do this. So now we're going to go ahead and get an account that we're going to generate. You can see the account address down below. I'm going to use a previously used app ID that I generated earlier before running this. This verify function is going to fail. because it's too expensive, right? So now you can see right down here in the output window, 700 is the budget, but the program cost was 1928. So this is what we're going to do. We're going to actually do the verify once, and then we're going to do two more calls, but we're not going to pass in any arguments. It's just going to be a blind call to get it back. Well, now you've expanded this to what? 700 plus 700 plus 700. So this answers, a question that a lot of developers have when they start going to budget costs. How do I expand the budget? And this is a really great example on how to do just that. So now we're just going to go ahead and sign this transaction, and it's going to spin out. You should see a success come out down below once it is confirmed. So there it is, confirmed in that round, and it is done. All right. So next up, let's go take a look at the next demo. This is going to be the inner transaction. So if we look at the PyTeal first on this, first of all, you saw this on the slide as well, but basically we're going to check that the sender is the app creator right here. And then we've got an inner transaction we're going to go ahead and do. And the sequence is going to be as follows. We're going to go ahead and begin the transaction builder. Then this is all going to build, the asset. So there, no, excuse me. Yeah, there you can see the manager, clawback, reserve, freeze, total. And well, that's it. And then we're going to go ahead and call it down here. And you can see it right there, and it's going to execute. This is the command, by the way, down here, compile teal of the approval program. And this, if I run this, this is what it's going to create. It's going to create this teal right here. There's a clear program. This is just going to have an int1 and return to it. So that is the lay of the land there. So let's go ahead and run this demo here, and we'll show you how this works. All right, we're going to sign our transaction. This, by the way, is the standard for any transaction in Algorand. You're going to create the transaction, then you got to sign it, and then you got to broadcast it to the blockchain. The send transaction is the one that will verify consensus rules, so there's no double spending, that sort of thing in that blockchain. And so this is going to go ahead and sign it. I'm going to run this, and then you can see down below the results that we're going to have from running this. And so here's the transaction that we're going to be running here. We're going to go ahead and fund this account with 0.5 algos. So this is in micro algos. And we're going to use this app inner transaction demo that we're calling from this Python SDK. So let's go ahead and do that. And then you can see down below the asset that will get generated. So there's our wait for confirmation method, and that will wait for it to, under 5 seconds typically to get into the blockchain. And down below you can see the asset information there that was created for that asset. And the crowd goes wild, right, on that one there. So cool demo on doing inner transactions. A lot of developers find that very handy and very excited about it, especially the ones that have been working with Teal. All right, let's get to the 99 bottles of beer demo on the wall, right? So we've got our song defined as a subroutine here called sing count, and we're just going to pass in the number of bottles of beer that we're on in the song, and then here's the lyrics, right? 99 bottles of beer on the wall, 99 bottles of beer. Take one down, pass around. 98 bottles of beer on the wall. So you got the -1 there, right? And then also you got the approval program. Once again, make sure that the app call sender is the app creator. There's your scratch variable. This is where you're going to store your integers for the loop, the upper and lower bounds, and then go ahead and do the singing right down there. And then the log is the method that we're calling right up there. All right, so let's go down and run this. All right, so we get down to the application. We'll hit our breakpoint. And what we'll see here is we're going to do the sign group. And this is, I'm also going to show you what happens when I'm going to create the dry run like we talked about so we can debug this in a minute. And I'm going to step into this so you can see what's going on there. So here's the source that we've generated. We saw the approval teal out there. And we're going to combine the app ID and the source. And then we're going to go ahead and get the account information. That's the account piece to the equation. And then we're going to create what's called the dry run request with the transaction, the source, and the accounts, and then the app. And then we're going to go ahead and write this out to the folder, the directory, so we can use that for debugging. And that's it. So let's go ahead and continue running this. And there's our song. How about that? So we got that all coming out. And now let's take a look at this in the debugger. So what I'm going to do here is I'm going to fire up the debugger. I got to do one thing first. I've been using Sandbox, by the way, in all these demos, and this is the URL. You need a token and a URL for that. And let me bring that up. No, I can't seem to find it here. I got to bring it up though, because I got to shut it down. All right, where is my Sandbox? There it is. Oh, okay. Oh, that's not it. Oh, man. Okay, so now we'll go ahead and do a, I'm just going to do a temporarily shut this down. So I can do this demo. Some of the ports conflict. All right, so now let's go out to the page. All right, and we're going to see here once I run this. Over here, we'll go ahead and hit enter right here. Oh. I was so smart to copy this ahead of time, and I've copied without the T. There we go. All right, there we go. So now we should be able to see that available over here in inspect. So we'll go ahead and bring this up. Here's the debugger, and what we're going to do here is step through it. Now I've got some breakpoints set in there. You can just step over, each line. You can expand out the scope here. You can see the global objects. You can see right there's the sender coming in. There's our scratch space. There's the arrays, and there's the transaction. So I'm just going to hit run. Now you can start seeing some of these populate. So now you can see I've got the array started up. There's the app ID that we have in there. And if I go ahead and hit enter, then we can also see in the scratch space the arrays now. You see at 99 starting up as well. And then you can also see the lyrics, right, that are going to be called from a subroutine, which is also new, doing subroutines. So I can just step through this, and then you can actually see it execute, and that's it. And it just went right down to nothing in the loop after that. So that is our demo on debugging, and as well as some of the really cool now things with the AVM. So getting back to my deck, I'm going to go ahead and show you a little bit more with reach. because this is really all about building dApps today, right? In this particular session, and I couldn't do one without that. And also, I did want to mention all the SDKs have a new call in it to support the getting of the actual address for the application ID. So there's the calls for each of them. So what is Reach? Well, it's a programming language. JavaScript, Python, more high-level language. It compiles and outputs to any chain with just a configuration chain, which is great. Mathematically guarantees safety. So there's verification built right in. You're not going to leave money on the table. And this is a very, very important thing when you're building smart contracts, is really the auditability of those contracts. You never want to feed into a contract, say, 10 algos and only end up with 5. You want that to end up as 0 when you get done. Otherwise, that money could be lost. And then you can deploy to many different, a few different blockchains. This is the architecture. You have front end and back end. Typically, you have that in the realm of client server design. No different here. Then you have on the back end is the important part. It's like JavaScript-like code. That's a reach file, and this is what generates and deploys and interacts with the smart contracts automatically. It's a solution implementation. You define your front end interfaces in it, and you define the participants, and you also verify and do commitment schemes as well. And I'll talk about all that in the code. And then also you have the front end now, which really has the logic for all the interact methods. And it also has blockchain specific code, perhaps might go in there as well. And you can do things like create accounts, fund accounts, all that kind of good stuff there. Compile and run it, and boom, you got yourself deployed a dApp to the blockchain. So how does Reach compare? Well, to Solidity development, for those that are familiar with Ethereum, basically with Reach, it's all one product. With Solidity development, each of these aspects of the development of a dApp uses multiple tools. You got tools up the yin yang to go ahead and actually create a dApp. You have to really piece them all together. With Reach, you got protocol design done with the programming language. You got the smart contract with the Reach compiler. You got middleware with the API. Also, you got the front end built with JavaScript or an RPC language, a remote procedure language for available for Python, Go, now C# as well. Testing, also verification. Every Reach compilation includes a thorough formal verification of the dApp, which is, like I mentioned, extremely important. And deployment, right? You got a lot of multiple blockchains. So there's two types of scenarios. One is local JavaScript, and that's where you're going to be instantiating a library, and then using stdlib, for example, to parse the currency. Then there's actually the RPC, or remote procedure calls, that you can use that use an endpoint to do the same thing. So now you can have your front end in many different languages, like you see over here, Python, JavaScript. I saw a lot of JavaScript developers that are on here. You're going to love this tool. And so now let's take a look at a Reach demo. Okay, so I'm going to bring that up. Find it a lot quicker this time. How about that? Okay, so let's go ahead and clear this. And let's do a Reach run first. Just show you what this. This is a game I wrote called Mora. For those that are unfamiliar, this is a very old game. I think in ancient times, Greece or Italy, maybe where it's a hand game. You basically throw fingers out. And so when you throw fingers out, like say I throw out 4 fingers, and then the opponent throws out maybe 1 finger. So that's going to total up to 5. And you have to guess simultaneously with your opponent what the total is going to be of the 2 hands. So that's what you're going to see run here. And it's going to go ahead and show you what's going on here with the with this particular game. So there we go. So Alice is and Bob are playing. We got some timeout capabilities in there too. We got to handle timeouts. And this goes until there's a winner. Sometimes it could be 1 round, sometimes it's several rounds. So there's the winning round right there. So let me explain how this works here. So Alice shoots 3 fingers, and Bob shoots 4. Alice guessed 5-7, so that was a draw. Now this one here, Alice shoots 2, Bob shoots 7. And she guesses 7. Bob shoots 2 and guesses 4. So 2 and 2 is 4. So Bob is the winner. And so that's what you see down here, and that they're doing some betting here, so they're going to get that that value. So that's how you run it. So we got 2 files here. Let's start out with the reach file, which is the back end file. So on the back end, what you see here is first and foremost, you've got your logic to the game, right? So this is the contract you're going to be creating. This is the rules of how this thing is played. The next section is very interesting. These are all the asserts, and you may have seen when I ran this, for example, that there was a little bit of a mention up front that all of the proofs, had met, and if for any reason it doesn't, it'll tell you that. In fact, let's just make a quick change to this transfer, for example. I'm going to say instead of transferring the wager from both, I'm going to just transfer 1 time the wager, right? And now if I run this again, this should fail because you're leaving money in the smart contract. And, this is how some big problems have happened in the past with blockchain smart contracts, is exactly what I'm showing you right here. It wasn't verified. It wasn't audited that this is a possibility. And when this runs, then what you'll see is the game is going to go ahead and croak right when it does this. And there it is. Okay, so it's telling you this would be false, right? That it's going to return false. That this particular this assert has got to be a balance of 0 at the exit of the application, and it failed. So this really is great. Up until this point, you had to hire an auditor to do something like this, and then if you had a simple change like this, you had to do the whole application over again. And this is very, very expensive and time consuming. And now with this approach, you really just have to audit just the changes that were done, and you have that done. So getting back with how this actually works. So these are all the asserts which drives the verification. Here we're defining the front end. The front end interface. So you can see I've got some functions up there. One is throwing the fingers, the other one's getting the guess, the other one's determining the winner, playing the winner, and outcome. And then we have a timeout type thing. Timeouts are very, very important because right here you see I've got a timeout on this wager. If Bob doesn't accept this wager, that five algos is sitting out there that algo did. And it's not like a website where you have a web application and you just leave it alone and you come back the next day, it's the same way. You can continue where you left off. This is not the case. This is a slice in time you're dealing with here. And you cannot have a contract lock these things up. So you really have to be aware of things like timeouts and deadlines for responses from all of the participants. And so you can see participants here. We've got a couple of participants with Alice and Bob. She publishes the wager, commits that to the blockchain. And then Bob's got to accept the wager. And then we come down. Now here's our while loop until we actually have it succeeded. Here we're actually going to salt the value of the fingers. We don't want to publish the actual fingers and guess yet to the blockchain because that'll be an unfair advantage to Bob. You'll be able to see that. So that's what make commitment does. It'll go ahead and salt that away. And then you'll unsalt that down the road later, and then we're going to go ahead and publish that value, the _1 with the salted value, so it's out there, and then it's unknowable to Bob. So Bob goes ahead and then throws his fingers or makes his guess, and then it goes ahead and determines the winner right down below there. So the front end on this has the library, right, that you want to do. And then it also has the currency you're going to parse, your starting balance, ending balance. That's what you just all displayed. It has the logic here, right? It's got the random function to shoot the fingers. This is the guess that's going to take the number of fingers that you threw out as an argument. You're going to add to that a random number, winning number. This is the promise. This is all the wager that takes place. And then we close everything out. So that's a quick demo of Reach. I hope you enjoyed that. I am very excited about that project. I'm going to end with these. I know we're getting close to the end. Perfect timing. We do have some bounties I want to make you aware of. One is this game studio track, 150,000 algos at today's rate. That's, you know, a couple bucks an algo. So that's pretty hefty. And a lot of other ones that are really good too as well. A need for Teal smart contract tutorials, for example, for the site. I mentioned our developer office hours. Go out to algorand.com/developers. Also, we have a great hackathon underway. It's $100,000 worth of prizes. Innovate. It's under the Hacker Earth umbrella. So Algorand-innovate, hackerearth.com. Runs now through middle of January. So you got some time to really build a great solution there. Our dev portal, I can leave this up. You can take a picture of it or scan in the Discord server. I want you all to join that. And people asking, yeah, can I get some support on some of the problems I'm having? Yeah, well, Discord server is just that. There's a thriving community there, over 12,000 developers, and a lot of them are helping out. And so let's wrap up with a summary here. So we talked about getting started, some of the basic tools, and the portal, developer portal, has really got everything there to get you going. Also, we started talking about the AVM, showed you examples and how to expand your budget for smart contracts, showed you what intertransactions were about to build like an asset, right? Create an asset or something like that, or any transaction really. Log support, we showed you PyTeal, generating Teal code, and as well as debugging and how you go ahead and do that. And that PowerPoint slide is at the bottom of the URL. There is the QR code. I asked the moderator if she can put that in, if they can put that into the chat somehow. But if not, I'll leave it on the slide momentarily. And I think that's it. This deck also has some other links in it too, but I'll just leave this up here for now. I'm going to go back to stop sharing the screen here. And I think we are going to go over to the help answer some questions over at the virtual booth. I think that is the next thing we're going to do. Let me go ahead and stop sharing the screen and say hi to everybody. And I think we're in good shape here, right? Finishing right on time. And we'll mosey on over to the Algorand virtual booth. I've also got Jason Weathersby is going to be joining me. He heads up DevRel here. So hopefully we'll get some of your questions answered there. All right. Thanks, everybody. See you over there.